class. This is our lesson in Theory of Architecture 1. This is primary elements of design. Okay, so our course outcome at the end of the lesson, students are expected to identify, define, and evaluate the primary elements of design, to relate the primary elements of design in the context of architecture, and to visualize primary elements as design element through architectural examples. For your reference, you can refer to Francis D.K. Jane, Architecture, Form, Space, and Order. This is a quote from Paul Lee, defining the four design elements: point, line, plane, and volume. Later we will discuss it one by one. So the primary elements of form in the order of their growth from the point to a one-dimensional line, from the line to a two-dimensional plane, and from plane to a three-dimensional volume. Later we will discuss one by one these primary elements. So the primary elements are: first, point, the first element of design. Two is a line connecting points and the first element that has dimension. Next is plane, defining surfaces. And lastly, volume, the essence of three-dimensional space. First, we're going to discuss point. Point indicates a position in space. A point marks its position in space. Conceptually, it has no length, no width, or depth, and is therefore static, centralized, and directionless. So 2 points describe a line that connects them. Although the points give this line finite length, the line can also be considered a segment of an infinitely longer path. So sabi nga, the point has no dimension. So to visibly mark a position in space or on the ground plane, a point must be projected vertically in a linear form, tulad ng column, obelisk, or tower. So tulad dito sa sample, meron tayong circle. Kapag pinroject mo daw ito pataas, you will have a cylindrical shape object or structure. But if you look from the top, you will have a circle like this Tholos of Polykletos in Epidauros sa Greece. Then, if you move around the circle in any direction, you will create a sphere like this cenotaph for Sir Isaac Newton in his project in 1784. So other point-generating forms that share these same visual attributes are these: circle, cylinder, and sphere. So like this, a sphere in Las Vegas, one example of projecting or moving the circle around to create a sphere. 2 point. 2 points further suggest an axis perpendicular to the line they describe and about which they are symmetrical. So to create a 2 point, you will have a movement and you can also show direction. By connecting the 2 points, you will create what we call a line. That is the second element which we're going to discuss later. So 2 points established in space by columnar elements or centralized forms can define an axis. An ordering device used throughout history to organize building forms and spaces, like this Torii Gate in Ise Shrine in Mie Prefecture in Japan. So Torii is like a portal. It's an afterlife portal for Japanese, like a gate. And this one at the bottom is the mall in Washington D.C. So it has 2 points, one from the Capitol and one on the obelisk side. So 1 point here and 1 point there. It'll create a connection between the two, even there's no direct line between them. So for the Torii Gate, like this one, you have to put it here and put it here. You create a horizontal line off to create the gate. And also the point here and the point there is going depicting the the physical world and the afterworld. So like this one. This is the actual photo of the Torii Gates. This is in uh, Fushimi Inari in Kyoto in Japan. So this one at the bottom picture is the mall in Washington, D.C. So this is the obelisk and this is the Capitol. So point here and point at the obelisk to create a line between the 2 points. Next, we're going to discuss line, primary elements, the second primary element. So line extended becomes a line. A point extended becomes a line. Conceptually, a line has length, but it has no width or depth. Whereas a point is by nature static, a line, in describing the path of a point in motion, is capable of visually expressing direction, movement, and growth. So now, you have a point here. If we project the point in any direction, like vertical, horizontal, or diagonal, you create a line. So a line, although a line theoretically has only one dimension, it must have some degree of thickness to become visible. So although a line doesn't have a width, it has a thickness. So it can be a fine line or a thick line. It can be a cursive or a wavy line, a dotted line, a hidden line, or a series of uh, lines. Vertical lines is still a line. So a line, this one is a line of letters, characters and numbers, and can be a line of made of objects. The orientation of a line affects its role in the visual construction, while a vertical line can express a state of equilibrium with the force of gravity, symbolize the human condition or mark position in space. So like this. So you have a lines, horizontal lines. This is the x-axis and this is the y-axis. So merong nakalagay ditong object na nakahiga siya and this one nakatayo siya dun sa could be a ground plane or the horizon or could be the ground. So this one it seems like floating because of the line or maybe a far away from the ground or from this point. So like this, the sunset, it looks like it's a setting sun because it's far away from the ground. That is made because or it was created because of these lines. It makes a it created a sense of depth or a depth of field between this object and this object. Yeah. So that one characteristic of or illusion of these lines. An oblique line is a deviation from the vertical or horizontal. So it's not always horizontal or vertical. It has sometimes it's diagonal or uh, oblique. So vertical linear elements such as columns, obelisks, and towers have been used throughout history to commemorate significant events and establish particular points in space. So in the context of architecture, we can use linear elements like vertical lines to depict this significance or milestone or relevant event. Like this bell tower in Voksleniska in Imatra, Finland, designed by famous architect Alvar Aalto in 1956. So this is the bell tower. So this is what it looks like in the real life. So they have a vertical linear element there. Also, in prehistoric time, we have what we call menhir, a prehistoric monument consisting of an upright megalith, usually standing alone, but sometimes aligned with others. So other elements are the column of Marcus Aurelius in Rome to commemorate the emperor's victory over Germanic tribes in Danube. Next is the obelisk of Luxor that marked the entrance to the Ammon temple at Luxor in It was given by Viceroy of Egypt, Mohammed Ali, to the Louis Philippe Evans toll in 1836. So these are vertical linear elements. One of the applications of a line, the second primary elements. So this one, vertical linear elements can also define a transparent volume of space. Transparent meaning you cannot see it physically, but by having these vertical lines, you created a square shape by connecting those lines, right? So these lines, this tower on the corner of this mosque, the Selim Mosque in Edirne, Turkey, are what we call minaret towers. Uh, Four minaret towers outline a spatial field from which the dome of the Selim Mosque rises in splendor. So this is what it looks like in real life, in actual. So linear elements are not always vertical. Linear elements that possess the necessary material strength can perform structural functions. In these three examples, linear elements express movement across space. It provides support from an overhead plane and form a three-dimensional structural frame for architectural space. Like this one in Salgina Tobel Bridge in Switzerland, designed by Robert Maillard. So we have a horizontal beam and girders, also the road. It has a bending strength to span the space between the support and carry traverse load, also supported by these uh, vertical elements. So this is what it looks like in actual. Also this one is in Katsura Imperial Villa in Kyoto in Japan during the 17th century. So we have linear columns and beams together form a three-dimensional framework for architectural space. So the whole space, as you can see, is horizontal, but because of the columns, it has a contrasting effect to uh, to negate or contrast the horizontal uh, shape of the structure. So this is what it looks like in actual Katsura Imperial Villa. So these columns are in Greece, no? Directly on Athens. This is what we call the Caryatid porch. It is the sculptured female figures stand as columnar supports for the entablature. The entablature is the one, the big beam at the top of their heads. That one. This one is a real life, real actual photo. So these female figure columns are what we call the Caryatid porch. So linear elements can also be not only in the elevation but also on the plan. A line can be imagined element rather than a visible one in architecture, like this one in Villa Aldobrandini in Italy, designed by Giacomo della Porta, and House Number 10 in 1966, designed by John Haydock. Very linear in plan. So if you move a line, you can create a plane like this one. Can be an can be a invisible plane or a physical plane if we move a line. So two parallel lines have the ability to visually describe a plane. A transparent spatial membrane can be stretched between them to acknowledge their visual relationship. Now with this column, series of columns, it looks like a vertical lines, but we have this invisible or transparent spatial membrane that creates a rectangular shape. And also this one, if we put arcs above, then we create a plane. Same with this. If we have a windows or fenestration or wall openings, we create a physical plane. And also with this one. So that leads us to the third primary element, which is plane. Plane, a line extended in a direction other than its intrinsic direction, becomes a plane. Conceptually, a plane has length, width, but it has no depth. So we go back to the point. Point doesn't have any dimension or size. So it just demarcate a position within a space. But the line, if we connect the 2 points, we create a line. It has a length, but it doesn't have a width or depth, right? But for plane, it has three or it has two dimensions. It has length and width, but it has no depth. So plane, it is said that shape is the primary identifying characteristics of a plane. So read that again. Shape is the primary identifying characteristics or characteristic of a plane. So that's identifying factor. If it has a object has a shape, then certainly it is a plane. It has a plane. It is determined by the contour of the line forming the edges of a plane, like this one, a rectangle, in a square, triangle, or circle. So if it has a shape, it also has a plane. So a plane doesn't have to be closed like this one. It is just a series of lines forming a triangle. This one also series of different lines with different lengths. So it's the as you can see on the edges, it's not really closed, but because of the shape, it creates an invisible plane. So plane in the composition of a visual construction, a plane serves to define the limits or boundaries of a volume. So later we will discuss what volume is. So if architecture as a visual art deals specifically with the formation of three-dimensional volumes or mass or space, then the plane should be regarded as a key element in the vocabulary of architectural design. So it starts of something architectural. So from the point we create a line, and then from the line we created a plane, and then from the plane we create a volume. So that's the start of something 3D or three-dimensional, because volume has three dimensions or measurements. So later we are going to discuss them. So plane in architecture define three-dimensional volumes or mass and space. So the properties of each plane, it has size, shape, color, and texture, as well as their spatial relationship to one another, ultimately determine the visual attributes of the form they define and the qualities of the space they enclose. So, in architectural design, we manipulate three generic types of planes. First is the overhead plane, wall plane, and base plane. So, overhead plane can be either the roof plane that spans and shelters interior space of a building. Next is wall plane, because its vertical orientation is active in our normal field of vision and vital to the shaping and enclosure of architectural space. Then we have base plane. The base plane can be either the ground plane that serves as the physical foundation and visual base for building forms. So read it again. We have the overhead plane, also known as the roof plane. Then we have wall plane and base plane, also known as the ground plane. A ground plane ultimately supports all architectural construction, along with climate and other environmental conditions of a site, like the topographical character of a ground plane influences the form of the building that rises from it. Like this one, the Scala de España, or the Spanish Steps in Rome, designed by Alessandro Specchi, designed the civic project to connect the Piazza di Spagna with SS Trinidad de Monti, and it was completed by Francesco de Sanctis. So this is what it looks like in actual. Next is the floor plane. So from the word itself, floor, it has a horizontal element that sustains the force of gravity as we move around and place objects for our use on it. like this emperor seat in the Imperial Palace in Kyoto, Japan in the 17th century. This is what it looks like in actual. So it has a ground plane for the floor plane. So the difference between ground plane and the floor plane is mostly outside of the structure, and floor plane is on the inside of the structure. So it's not always horizontal. The exterior wall planes isolate a portion of space to create a controlled interior environment. So it doesn't have to be always inside. Outside also is also defined by exterior wall planes like this Uffizi Palace, designed by Giorgio Vasari in Florence in Italy, like this one in real life. So we have that is the exterior. Now proceed to interior wall planes. Govern the size and shape of the internal spaces or rooms within a building. So any walls that is inside the building, like partitions or half partitions or division. So it's inside interior wall planes. So like this concert hall designed by famous architect Mies van der Rohe in 1942. So visualize this is the actual uh, photo of that concert hall, very minimalist. Next is we have the roof plane is the essential sheltering element that protects the interior of a building from the climatic elements. The form and geometry of its structure is established by the manner in which it spans across space to bear on its supports and slopes to shed rain and melting snow. So, like prehistorically, uh, it was visible already. Like this one, they use the term dolmen, a prehistoric monument consisting of two or more large upright stones supporting a horizontal stone slab. Sometimes they use it as a shelter if it's big, or a table, or an altar. For a rod also can be used as a marker for entrance or tomb. At the bottom photo is or sketch is a Robbie house designed by famous Frank Lloyd Wright in 1909 in Chicago. Because as you can see, there's a long span cantilever roof here. Yeah. Nung panahon na yan, napaka-rare pa yung may ganyang kalapad na cantilever roof because dati wala pang masyadong technology to support that long span. So these are photos in actual. Lastly, we have the primary element volume. A plane extended in a direction other than its intrinsic direction becomes a volume. So conceptually, a volume has three dimensions. It has length, width, and it has depth. So form is the primary identifying characteristics of a volume. So read it again. Form is the primary identifying characteristics of a volume. So it is established by the shapes and interrelationships of the planes that describe the boundaries of the volume. So it can be in any shape: triangle, mirrored triangle, square, sphere. If it has volume, then it has also form. Or form, if it has form, it has volume. So the three-dimensional element in the vocabulary of architectural design, a volume can be either solid space displaced by mass or void space contained or enclosed by planes. So later we will have some samples of that. So volume in architecture, a volume can be seen to be either a portion of a space contained and defined by wall, floor, or ceiling or roof planes, or a quantity of space displaced by the mass of a building. Take, for example, for this Notre Dame du Haut, designed by Le Corbusier in France, Ronchamp, France. This is what it looks like in actual. So many forms, right? It's this one like a form, shape, different shapes. It has wall planes, it has a roof plane and a ground plane. So it created a mass or a form or volume. So building forms that stand as object in the landscape can be read as occupying volumes in space. This is the Villa Garces also in France, designed by Le Corbusier. This is what it looks like in actual. So the volume that stand as object in the building forms that stand as objects in landscape can be read as occupying volumes in space, like this one, a Palazzo Tien in Vicenza, Italy, designed by Andrea Palladio, a Renaissance advocate. Interior rooms surround a cortile, the principal courtyard of Italian palazzo. So the volume is not always the solid or the tangible objects like the walls. It's not always like that. Volume also refers to the void, the space within, like this, that is enclosed or created by these solid uh, or physical walls, right? This is also a volume because it has length, it has width, and also has height, right? So it has also an invisible volume. So as we review, we have a point. It indicates a position in space. While line, it has a properties of length. It has direction. It has position. Plane has a properties of length and width. It has shape. Its identifying factor or characteristic. It has surface, orientation, and position. Plane can be measured in units using square meter, right? Length times width equals area, right? And the unit is square meter. And also, lastly, for volume, with the properties length, width, and depth, form and space, it has surface, it has orientation and position. So the three dimensions of volume is are length, width, and depth. So the unit for volume, the formula for volume is length times width times height equals volume. So the unit for volume is cubic meter. So according to architect Louis Kahn, even a brick wants to be something. That is one inspirational message to all of you. And that would be all for our lessons, primary elements of design. Thank you for listening.